Often when I start teaching this and I say I'm going to save division for tomorrow, everybody gets super pumped because they're like, I don't want to do the division. That sounds hard. But we talked about yesterday that it's really the same thing as what we were doing yesterday, right? We're still multiplying. We're doing the keep, change, flip. So, taking a look at number 1, it looks trickier, but all I need to do is keep, do you have a pass? Perfect. I need to change from division to multiplication, and then, thank you, and then I need to, I need like a pass from the office. Oh, that's what they told you to give you?
Yeah.
Okay, I will go with that then. Okay. 12y squared over x to the 4th y. So again, if you want to write yourself a reminder note about what we did, this was a keep, change, flip moment. So again, all the way back to middle school, probably when you saw that for the first time, but it was just probably with numbers. Okay, I heard there were going to be storms today. Here they come. All right, so remember that there's really a coefficient of 1 hiding there. So if I multiply my coefficients, 12 times 1 is just 12. There are no buddies for x squared or y squared, so I have nothing like where I'm going to add my exponents together there. They're just going to kind of mush together. In the bottom, again, there's kind of a 1 hiding here, so when I multiply the 4 and the 1, I get 4. And then I've got x to the 4th, bless you, and y to the 1st. Okay, so let's go through this one piece at a time, just like we did yesterday. So let's start with the 12 over the 4. 12 over 4 is going to reduce to what? 3 over 1. Now, I probably don't need that one, but I'm going to put it there for now. Let's go to the x's next. Alright, so pretend that y isn't lurking. In terms of the x's, what am I going to end up with? 2x in the bottom. And by 2x, we really mean x squared, right? And then look at your y's. How many y's and where are they? 1 in the top. So this would be my final answer. I could rewrite it a little bit more simply and just say 3y over x squared. This isn't wrong though. You could leave this as your answer. That would be a-okay to have the 1 there. It just doesn't have to be there. So remember, we thought about these as subtracting and it lives where the larger exponent is. Or if it helps you, bless you, remember that you can write it out. So for example, if I just look at the x's for a second, remember x squared is the same as x times x, and x to the 4th is 4 of them. Cancel, cancel. There are 2 left in the bottom. So again, just a reminder that you can always draw that out if that works for you, if that helps you more. All right, we ready to flip? Okay. On the back, we are going to talk about 2 things. We're going to talk about thinking about where things are undefined, and we're also going to talk about beyond that, like going through and doing the problem. All right, so let's look at number 2. We're going to do a keep, change, flip. I'm going to keep the first fraction. I'm going to change, and then I'm going to flip the second fraction. So I'm going to have 2 fractions, and they're going to be multiplied to each other. Notice I didn't put anything in yet, though, because I'm going to start going through and factoring. So unlike the last one where we multiplied right away, is this going to turn out nice if we start multiplying? No. So let's start by factoring this one. So remember, I told you my order that I like to go with. Do I have a common monomial? Yes, no? No. Do you have a difference of squares? So I'm just looking in the numerator right here. Do I have a difference of squares? No. Is it a trinomial? Yeah. So let's see if we can factor it in that way. So 2 sets of parentheses. I know x times x is x squared. What multiplies to 15 but adds to 8? 3 and 5. And everything is positive because everything's positive in the problem. Down here, I want to take out what they have in common, because you see how when I look at my first thing, common monomial, I see, yep, that's something I can do. What can I take out from both? 3. And I'll be left with x minus 3. All right, let's look at our next fraction. In the top, what do I have there? Trinomial. So I'm going to go 2 sets of parentheses. X times x is x squared. What multiplies to negative 21 but adds or subtracts to 4? 7 and 3. In the bottom, I have a difference of perfect squares. Remember, we get a plus sign and a minus sign for those. If I square root x squared, I get. And if I square root 25, I get 5. Okay. Now, I know that we have a situation where we have 2 separate fractions. We can cancel any, yeah. Oh, I didn't flip it. That's a very good point. So let's make this a division, because I did not flip yet. Let's shimmy that back into a division. You are so right. I got so intense on factoring that I didn't flip. All right, thank you. All right, so let's leave the first fraction alone. And let's take our second fraction and actually flip it this time. Thank you. I was planning to do 2 things at once, and that did not happen. Thank you, Casper. Okay, now they're flipped. All right, so we're going to think of this as one big old fraction. Anything from the top can cancel with anything from the bottom. Do you have a pass? Did you put it on my desk? Oh, you put it right here. Just kidding. So what can cancel? No, the x minus 3's can't cancel anymore because they're both in the same spot. Can anything cancel? It doesn't look like it. Okay, so we're just going to condense all this down together. So in the top, we have x plus 3. Do you see how I have 2 of these? I'm going to rewrite that as x plus 5, that set of parentheses, squared. I've got an x minus 5. That's not the same thing, so I can't kind of group that with the others. In the bottom, I have 2x minus 3's. So I'm going to rewrite that as that set of parentheses squared, and then I have an x plus 7. There's nothing that can cancel. That's a bummer. So let's stop for a second and take a look. Yesterday, we talked about multiplying it out. Can I leave this as my final answer, or do I have to multiply it out? Yeah, you can leave it. So this whole thing is my final answer. Okay, ready for the next one? Okay. This one looks even worse, but it's not. We have in this situation a fraction within a fraction. So what this is really saying is I have 20 over x minus 1 divided by 6 over 3x minus 3. So I can separate them. Each of those lines means division. Right, this time I'm going to flip and multiply my first try. I just know it. My first fraction I'm leaving alone. My second fraction I'm flipping. So the 6 was on top. Where does the 6 go? To the bottom. Now, I do need to factor, but the only thing that can factor is what can I take out of each term? A 3. So if I pull out a 3, I'm left with x minus 1. Can anything cancel in this one? Yeah, x minus 1s. And so then I have in the top 20 times 3, which is 60, all over 6 times 1, which is just 6. And what do I get when I divide that? 10. That was a good one. All right. Now, the other thing I want to do is I want to go back to yesterday for a second and talk to you a little bit more about the denominator and when it can't be 0. Let's go back to number 3 for a second. So I want to kind of add on a little bit to our notes from yesterday. So when they ask you where it's undefined, because some of the questions in the homework have been doing that, and eventually like we'll have a quiz and a test and we'll get into that more, but you go back to the step before stuff cancels. So you go back to the step where all the things are still there. So do you see how in this step I still have all my parentheses? I've already tried to cancel some of them out, but they're still all there. Agreed? Okay. So you go back to this step when you're trying to find things that are undefined, and you're going to say what x cannot equal. So this is again when we're looking for stuff and we're looking for where something is undefined. All right. If I look at, first of all, what can't our denominator be? 0. What would make this denominator 0? How about this one? -7. So x cannot be -1 or -7. So when they ask me where it's undefined at -1 and -7. So this is a situation, sometimes we like to say what x is, right? But in this case, there are infinitely many numbers that x can be. It's easier for me to give the short list of what it can't be. Does that make sense? So if you come across undefined, you go back to the step before you simplified and you look at the parentheses to see what would make them 0. Good? Okay.